Great. Good afternoon, everyone, and welcome again to the Southwest Climate Adaptation Science Center 4th National Climate Assessment webinar on water resources. I'm Greg Garfin. I'm the University Director of the Southwest Climate Adaptation Science Center, or Southwest CASC. We will be talking about the results from the 4th National Climate Assessment. Just to remind you, National Climate Assessment was mandated by Congress back in 1990 with the Global Change Research Act. And as it says here on the slide, the purpose of the assessment, which is to really summarize the work of the U.S. Global Change Research Program, represented by the 13 agencies whose logos you see in the slide, is to assist the nation and the world to understand, assess, predict, and respond human-induced and natural processes of global change. The 4th National Climate Assessment consists of 2 volumes. The first, the Climate Science Special Report, which was released in 2017, and that report analyzes trends in global change, including human-induced and natural trends, and projects trends for the upcoming 25 to 100 years, and it's portrayed in a really usable and useful website. And then last fall, approximately a year ago, the second volume of the 4th National Climate Assessment on Impacts, Risks, and Adaptation was released, and this analyzes the effects of global change on the natural environment, agriculture, energy production and use, land use, water, transportation, human health, human social systems, and biodiversity. Today, we will focus on the results from 2 chapters, primarily the Southwest chapter, one of the regional chapters in the 4th National Climate Assessment, and also the water chapter in the assessment. Our speakers include Keely Brooks, a climate change policy analyst with the Southern Nevada Water Authority. She's also the former chair of the Water Utility Climate Alliance and one of the co-authors of the Southwest chapter of the National Climate Assessment. And then Brad Udall, senior water and climate scientist and scholar at the Colorado Water Center at Colorado State University. I'm sure Brad has 10 other titles, and maybe Keely also has 10 other titles. Brad was also a co-author of the Southwest chapter in the 4th National Climate Assessment. We will be taking questions after Brad and Keely's presentations, and you can type those into the Q&A window. And we look forward to a healthy discussion, and we'll turn it over to Brad, I believe, to start.
All right, so this is Brad Udall, and I hope you all can see my screen now. Thanks for joining us. So I'm going to open with the general findings from the National Climate Assessment, and Keely's going to follow up with some specifics from her utility Southern Nevada Water Assessment. This opening image was featured on the 2nd volume of the National Climate Assessment, and it's a fire at Lake McDonald in Glacier National Park in August of 2018. You may recall, if you live in the Colorado River Basin, that that was the warmest and driest water year on record. And August was certainly a good example of that, and it was west-wide, hence the fire image here. Craig laid out the two different reports here of the NCA4, and I'll note that volume 1, which came out in 2017, was really a state of the science. It's equivalent of working group 1 of the Intergovernmental Panel on Climate Change. And volume 2 is more like working group 2 of the IPCC that dealt with impacts, risks, and adaptation. I'm going to talk about both of those. I'm going to end and just chat a little bit about the IPCC 1.5 degree special report and then end with some closing thoughts. So volume 1, released about 2 years ago, was 2 years in the making, had 60 co-authors, 15 different chapters, major findings, unambiguous global warming trend, humans, of course, the dominant cause of that. They noted that climate will continue to change this century and beyond. Of course, the magnitude of those changes will depend upon our greenhouse gas emissions trajectories, and an average increase of 2 Celsius to over 5 Celsius possible. And one thing that's come up recently on my radar, and should be on your radar too, when people talk about these average increases, those are global. And because 70% of the globe is ocean, we're going to see a higher increase over land. And so just keep that in mind when people talk about 2 Celsius or 3 or 4 Celsius, higher over land. To stay below 2 Celsius, we need significant reductions in greenhouse gases by 2040. And this image on the right just shows how 11 of the hottest years on record have occurred since 2005. And it looks like 2019 is going to be a top 2 or top 3 year in temperatures. Report also notes this idea that unanticipated changes are certainly quite possible. That report also noted how human activity is the primary driver of our global temperature rise. This image shows the change in radiative forcing from 1750 to 2011 at a little under 2.5 watts per square meter. You can see human caused there in red, solar just a tiny little impact, and volcanic actually a negative impact. Report noted that 92% to 123% of the observed 1951 to 2010 change was from humans. And you might ask, how can the human contribution be greater than 100%? And the answer is that aerosols that humans emit would actually be cooling the climate if there were no additional greenhouse gases being added. Out of that volume 1 were a number of projections dealing with the water cycle. And the first one was, these projections show consistent declines in soil moisture. The image here shows end of century higher emissions, so RCP 8.5 watts per square meter projections. The projected changes in winter, spring, summer, and fall. And you see only in Canada does the soil moisture increase during any of these seasons. Elsewhere, it dries consistently in North America. Report talked about an increase in frequency and severity of West Coast atmospheric rivers, and an increase in dry days, that is days without precipitation, a decrease in days with modest precipitation, and an increase in days with the most precipitation. We see this whole shift of the probability distribution of how precipitation will occur to these very intense events. An increase in the severity of the most damaging hurricanes, and many kinds of changes in future snow. So reduced northern hemisphere snow covered extent, that is to say the actual area that's covered, and we've already seen this, that will continue. More precipitation as rain rather than as snow. Reduced western US snow water equivalent, and of course earlier spring melt and runoff in the western US. Moving on to volume 2 that came out a year ago. So it came out on Black Friday, and frankly, the lack of news on Black Friday was to the benefit of the National Climate Assessment, and it got covered for almost the next 2 weeks. There were almost 400 authors, 29 different chapters. Greg showed the slide earlier with those different chapter lists. And I just want to point out 4 major findings. We're already feeling the impacts of climate change, and those impacts are being felt in terms of increases in fires and floods and droughts and hurricanes. Future impacts will disrupt many areas of life. Without substantial and sustained mitigation and adaptation, these impacts will cause growing losses to infrastructure, property, and impede economic growth. And of course, as is true of every assessment of climate change, quality and quantity of water always comes up as something that's changed and will continue to change. The second volume had 2 chapters appropriate to our webinar today, one on water specifically and the other on the American Southwest. And so out of the water chapter, they noted these changes in water quantity and quality. They noted that variable precipitation and rising temperatures are intensifying our droughts, increasing heavy downpours and reducing snowpack. More rain, less snow is changing the timing of water supply and demand. Groundwater depletion is exacerbating drought risk. And the image here out of the assessment shows 2 time periods, the upper one from 1900 to 2000 and the lower one from 2001 to 2008. And you'll note the High Plains Aquifer there in the center of the country, and both the upper and lower image in orange and red respectively show significant declines occurring in that part of the country. And elsewhere one sees declines as well, with the exception of those blue areas in both images, in the upper image in the Pacific Northwest, Snake River Plain, and portions of Washington. And interestingly, in the lower image in southern Arizona, which I assume but don't know is due to some of the Central Arizona Project storage that's been ongoing. They note that surface water quality is declining, and these declines are due both to water temperature increases and heavy downpours that can mobilize sediment in particular. These changes present an ongoing risk to coupled human and natural systems just because we're also tied into the water cycle. Continuing on with the water chapter key messages, they talk about how deteriorating water infrastructure is at risk. And my image here is from the Oroville Dam spillway failure in 2017. This occurred during a large atmospheric river event in California. This is, I believe, the highest reservoir in the U.S., the tallest reservoir in the U.S. And the spillway was designed and built around 1960 and failed catastrophically, as you can see here, causing the evacuation of nearly 200,000 people in the communities below for a number of days until the situation stabilized. This is true of the risk to our infrastructure exists in part because much of it's aging, and this deteriorating infrastructure compounds this climate risk. We see where extreme precipitation events can lead to severe floods and greater risk of infrastructure failure. One interesting thing that's been noted since at least 2008 in a now very famous Science Policy article is that infrastructure design, operation, financing principles, and regulatory standards typically don't account for a changing climate. And our current method of managing risk does not often consider the impact of compound extremes and the risk of cascading infrastructure failure like happened here. One more slide on these water chapter key messages. Water management in a changing future. The current strategies that we have, they're often, in the case of the Western U.S., implemented through records of decision supported by an environmental impact statement, such as governs how we operate the Colorado River. These strategies don't address risks that change over time. We put in place a single strategy that's supposed to last for an extended period of time, and we aren't able to deal with risk that changes through time. regulatory and institutional constraints to more flexible strategies, currently constrained options. And the classic case here is U.S. Army Corps of Engineer rule curves, which govern how high reservoirs can be in the spring in the American West to protect against flooding. Those rule curves are fixed. They're often, again, set through an EIS process, and you cannot change them, even if in a climate change world, we know we're going to get bigger storms in the spring that may, in fact, exceed the probable maximum flood for which the reservoir was originally designed. Moving on to Chapter 25, the Southwest chapter, you can see in the upper right corner here the 6 states that the chapter covers. And here's a list of the author team, including our very own Greg Garfin, who is the non-federal chapter lead, Patrick Gonzalez from the National Park Service. You can see Keeley's name here, and a number of other authors from universities and federal agencies throughout the West, as well as the occasional NGO. These are the 7 key messages out of the Southwest chapter, and I'm not going to walk you through them, but I would like to point out that water resources there is the first key message, and the notion of water rippling through these other messages is in ecosystems and ecosystem services in terms of drought. It's in indigenous people in terms of drought. It's in energy in terms of energy needs for cooling and thermal power. And of course, it's in key message 6 dealing with food, where our food supply is vulnerable to water shortages. The messages here in the dealing with water, we talked about how water supplies have declined, that we need flexible water management techniques that can address changing risks over time. And then here's a tie to forests and ecosystems, that that natural habitat, clean water, economic livelihoods have declined as a result of recent droughts and wildfire. The image here is a composite dealing with the Colorado River that shows declines long-term in Colorado River flow in the upper left, shows significant declines in Lakes Powell and Mead in the upper right, shows the significant increases in upper Colorado River Basin temperature in red there, lower left of about 2 Fahrenheit, and then relatively flat precipitation dating back all the way to 1895. We talk also about how greenhouse gas emission reductions, fire management, and other actions can help reduce future vulnerabilities of ecosystems and human well-being. We note that food production in the Southwest is especially vulnerable to water shortages because much of this food production is dependent upon irrigation, which in turn is dependent upon precipitation. Increased drought, heat waves, and reduction of winter chill hours can harm crops and livestock. And one thing that drought does is it leads to competition for water among ag and energy generation and municipal uses, and thus leads to increased future food insecurity, because oftentimes agriculture is on the losing end of some of these battles, unfortunately. Let me close and just talk about the IPCC special report that came out roughly the same time as the NCA a year ago. They talked about how it's almost warmed a degree Celsius, that 1.5 Celsius would be damaging, 2 Celsius approach intolerable, that current promises in terms of the Paris Accord to cut emissions lead us to about 3 Celsius, although I'll note we're not on path to even meet those promises. To avoid 1.5 Celsius warming, we need unprecedented actions, including steep downward emissions by 2030, and there's no historical analog to what we need to do to get these emissions down. Not that it's impossible, but we don't have that analog to look to. My takeaway on this report is that every 0.1 Celsius warming is important, and there's no cliff beyond which it's too late to act. And that at some point in time, we're going to talk a lot about negative emissions, how to pull carbon out of the atmosphere. Here's a look at kind of the summary, my final slide. The image is how wildfires with climate change are actually we're now doubling the forest area burn because of these hotter and drier conditions in the American West. And rather than walk us through each of these changes, I want to go back. I want to just focus on this final bullet here. Water management strategies that account for climate can reduce risks, but little implementation so far. But some people actually have really been on top of this, and that includes Southern Nevada Water Authority and what they've done to get ready for this. The utilities that have not prepped are the smaller ones, right? The ones without the resources to do this. But the bigger utilities, I would argue, in the American West, actually entities like Metropolitan Water District, Southern Nevada Water Authority, Central Arizona Project, Denver Water, and others have the resources and talents to begin to deal with this. And that's what Keely's going to talk to us about next.
Thanks, Brad, for your insights and reflections on these water-related findings from National Climate Assessment, fourth National Climate Assessment. We're going to switch over to hear from Keely Brooks from Southern Nevada Water Authority.
Okay. Can you hear me okay?
Yes, we can.
Excellent. Well, hi. Good afternoon. And Brad, thanks for setting that up for me so well. I also just want to thank Greg for inviting me to present on this today. And also just to acknowledge the tremendous efforts that the NCA authors put into putting together both volume 1 and 2, but especially from my experience, the tremendous effort that Greg Garfin and Patrick Gonzalez and of course Brad Udall put into specifically like the water components of the Southwest chapter. And it was really an honor to me to be able to contribute even in a finite way to this effort. So this afternoon, I'll just touch on a few of the key themes that Brad already highlighted. And really my goal is just to talk about how we've experienced some of these key themes and messages at the Southern Nevada Water Authority and how we're working through that. So just what are these key themes? These are threaded throughout the Southwest chapter and should sound familiar to you. And so my presentation will just, again, show how these general observations are being borne out and are reflected in my experience and our experience at the Southern Nevada Water Authority. But first, I wanted to give you some background on who Southern Nevada Water Authority is. So geographically, we're in the Southwest, very southern portion of Nevada. We're the wholesale water provider to a region that's about 1,600 square miles in area. For scale, that's an area bigger than the state of Rhode Island, so quite a large area. We serve water to about 2.3 million residents, mostly in the greater Las Vegas metro area, and that means we get a lot of visitors. So we have to provide water to those visitors, which is about 43 million people annually. You probably already know that the City of Lights, Las Vegas, is in the desert, and so we receive a very small amount of precipitation annually, only about 4 inches per year. In contrast, Seattle, Washington gets almost 10 times that amount. So where do we get our water? No surprise here, we get most of our water from the Colorado River, which Brad already talked about the Colorado River and some of the challenges that or observations we've seen on the Colorado River so far. So yeah, we get 90% of our water from the Colorado River. about 10% is from groundwater locally. And the Colorado River provides water to 7 states and Mexico. And we in Nevada receive the smallest share at a mere 300,000 acre-feet annually. So that's less than 2% of the water that's shared among the other states in Mexico. So a very small fraction, but it's very important to our water supplies portfolio. The Water Authority was formed in 1991 to ensure that we would manage that limited or those limited water supplies for our growing community as well as we could. And we're required to plan for 50 years of water supply, given different growth conditions into the future. And we manage the conservation programs that we do here in our community locally, and encourage the retailers that are our member agencies to implement as well. And this is really one of our top tools to enable us to live within our water means. And of course, along with providing that water, we need to make sure that we're delivering the highest quality water possible and meeting or exceeding the standards, water quality standards. To do all of that, of course, we have to make sure that we have the infrastructure in advance of growth to provide the water, and make sure that it's being maintained. And of course, it's our goal to do this while protecting our environmental resources. This is an image of our regional water system. And you can see we withdraw water from Lake Mead. We withdraw the Colorado River water from Lake Mead. We have 3 different drinking water intakes. And then that gets conveyed to 2 different drinking water facilities next to the lake. So we're really, relative to other metropolitan areas that use Colorado River water, we're really close to our water source. I'm about 30 miles right now from Lake Mead. So after treating the water, it gets then pumped. We have numerous pump stations and major reservoirs, and then large transmission laterals that provide the wholesale water out to our 7 different member agencies that are the retail providers. Not all of our member agencies are shown on this, but I wanted to point out the fact that all this infrastructure that we maintain and build operate under specific operation ranges, right? And that building them traditionally has always assumed stationary climate and hydrologic conditions. So the impacts and the changes that we're experiencing and expect to experience in the future is really kind of creating a whole new challenge. And Brad alluded to that earlier in his presentation. This slide here might be familiar to you. So it's meant to show just the dramatic impact on our reservoir where we withdraw water out of Lake Mead, how between 2000 and 2019, overall snowfall and runoff into the Colorado River Basin were well below normal, representing one of the lowest 20-year periods on record. And although we had a really good winter in 2019, the persistence of this long drought conditions have resulted in significant water level declines at our major system reservoirs, and this is what that picture shows. In general, we've experienced about 130-foot decline in Lake Mead from its highest levels that you can see in 2000. Like I said, these images should look familiar because as Brad was showing, this is the image from the Southwest chapter of the NCA Volume 2. And lo and behold, Lake Mead, our reservoir, is literally like the poster child for long duration drought and intensifying droughts. one of the climate impacts projected for the Southwest, and talked about quite a bit in the NCA Southwest chapter. So what does this mean to SNWA? What are these projected impacts from climate change, and how does that translate to impacts we feel on the ground? The long-term drought that's been exacerbated by warming and climate change is expected to have other impacts. Obviously, as our reservoirs decline, we face water supply availability challenges. As temperatures increase, water demands can increase, or we anticipate them to increase, as evapotranspiration of outdoor plants will need more water, and as those the season in which we have to water our landscapes increases, the duration of that season increases. Also, just the fact of declining levels in our reservoir causes changes in the dynamics of the lake, and we get increasing water temperatures, increased algal blooms. And then finally, as I alluded to before, because we've constructed our infrastructure and facilities to operate in a specific under certain conditions, as we move out of those conditions, we're really facing uncertain times. And then I just wanted to mention just briefly that we are starting to explore what the direct impacts of extreme heat will have on our employees. We have 1,200 approximately employees, and half of those folks work outside. So, you know, what does that mean, and how can we make sure we're protecting them? So I thought it would be good just to walk through what has happened over the last 20 years in terms of how declining lake elevations impact us. So back early on, as the onset of drought happened, we had to change our operating plans and how we operated our intakes. And at that time, we only had 2 intakes, as shown here in the cross-section. And so as the level of Lake Mead declined, the warmer surface water, which has kind of more poor quality water, was getting closer and closer to our intake. So it was costing more money to have to treat that water. And so in 2004, we constructed this extension to our first intake in order to access that cooler water that's lower in the water column to avoid higher treatment costs. And then in 2005, as projections indicated that we could be facing even lower elevations in our reservoir that threatened intake number 2, our board approved construction of our 3rd water intake, which has a price tag of $817 million. Let me see. So switching gears here, I just wanted to talk a little bit about now how we're seeing changes in the climate system. So we've talked about the long-term drought impacts on water quality and infrastructure, but we're also seeing just increased variability. And so, for instance, in 2018, the beginning of the 2019 water year, we're bone dry. This is a picture of the upper basin. We're in drought, and then Jeff Lucas from the Western Water Assessment did a presentation in September in 2019, just after that really dry conditions, and he noticed or identified, which a lot of people identified, that we were going from this really dry condition in 2018 to what he coined a snowpocalypse. And this image is showing the moment on March 7th when an avalanche starts to overtake trucks and the highway near Frisco. And so I just thought this was really the visual image about like how quickly these things can change. This is the long-term, this slide shows the historic February-March precipitation in the upper basin since 1900. So this is the values that's shown basically in the snowpocalypse that was in the previous slide. You can see that in 2019, the upper basin received near record precip and snowpack. So you would think, well, great, our reservoirs are going to start filling up again. We should be doing good. And yet it didn't translate into the expected runoff. So this is an image showing the combined contents or storage of Mead and Powell from 2000, where it was full over on the left side, and you see this long march of declines with a couple years where we start to refill a little bit, where we have a good year. And then just this blue circle shows really the very minimal impact that exceptional precip had on our reservoirs. And so shifting gears again, I wanted to then talk about what we're doing to adapt to the long-term drought, the water quality impacts, infrastructure, and then also how we're managing our water supplies and planning differently. So we're doing this in several ways. We're adjusting the way we plan. So SNWA, we have a new water resource plan that's due out by the end of the year, and it's expanded the number of planning scenarios to reflect supply impacts under a number of different hydrologies. So we're looking at average, dry, extremely dry, and climate change hydrologies. And in that document, we demonstrate how we can meet those the projected demands under these different planning assumptions. So we're taking a more flexible look at our planning scenarios. Also, we're taking advantage of those years that we don't use our full allocation of Colorado River water. What we do is we are then able to bank it, just like a piggy bank, and put it in storage, either through groundwater storage or recharge, or agreements that we've had at California and Arizona. And as a result, we've been able to store more than 8 times Nevada's 2018 Colorado River consumptive use. And then I also wanted to bring up that leveraging partnerships with our Colorado River Basin state and federal partners has been really important. Collectively, we've invested over $1 million in research to improve forecasting and projection tools that we rely on in the basin. And one of the funded projects that's due out here in the spring of 2020 is the State of the Climate and Hydrology Science Synthesis document pictured here on the left. We retained Western Water Assessment, and again, Jeff Lucas and his team is the lead author on that. So the goal of this synthesis document is to identify research opportunities to help us improve the tools water managers use in planning. Also, just want to mention that because our service area is not in the Colorado River, the upper Colorado River Basin, it's in Clark County, we're also conducting climate change research here locally as well. So that's kind of what we're doing on the water supply side, but we're also doing a lot in terms of reducing water demands. A very large part is managing and extending our supplies through local conservation efforts, and I'll go through that in a minute. But I also wanted to mention that we're also focusing, we're focusing on research into cooling tower technologies, because although 60% of our demands locally are attributed to the outdoor water demands, and that's because of consumptive use. We're finding that cooling towers used by high-rises have the second highest consumptive use locally. So this is an area that we think is ripe for investigation and hopefully application soon. And then also I'll talk a little bit more about the collaboration that we're doing with our Colorado River partners. So this slide just shows a general overview of the success of our Southern Nevada Conservation Program through implementing policy, pricing, education, and incentive programs. We've reduced water use and extended our limited water resources. And this program has helped us to reduce per capita water use by approximately 46% between 2002 and 2018, despite adding nearly 700,000 new residents. Here's a slide that just goes into a little bit more detail what those conservation programs are. One of our most effective is this Water Smart Landscape program, where we incentivize homeowners, business owners to remove the high water using grasses, get rid of those in the front lawns, and then replace it with Water Smart landscapes. And then this slide highlights some of the biggest achievements by the organization that we've done with our partners. We've worked tirelessly with our stakeholders to bolster Lake Mead water levels and to protect Colorado River operations for lower basin water users. And many of you have probably heard of the latest achievements, which was the passage of the Lower Basin Drought Contingency Plan, which ultimately provides the users more flexibility on the river. And because I'm running out of time, I'm not going to go through all of these bullets. So I mentioned the impacts associated with water quality. Here's a list of the infrastructure modifications, some of them, the biggest ones, that we've completed or are in construction, and that will help improve water quality and then improve access to our water supply. And then the last bullet on here identifies Lake Mead modeling. I just wanted to note that we also use a three-dimensional hydrodynamic model of Lake Mead to play out these what-if potential future conditions in Lake Mead. And this is another way that it's helping us in our planning efforts to deal with water quality concerns in the future. Finally, just briefly, we have an ongoing heat impact study. So this is looking again at direct heat impacts. We're looking at how this might increase the risk of heat stress to our personnel and also to our critical air conditioning systems that we rely on to cool our infrastructure. We've already identified ways to start enhancing education and outreach on heat stress and recognize where we need to focus on collecting more data in the field to help us adapt and reduce potential increased risks in the future. So this is my final slide. Again, just wanted to point out that these are the themes that we saw throughout the Southwest chapter. You know, impacts are here and now. SNWA clearly is feeling it. We've had some water quality and water quantity, or we're seeing changes in water quantity and quality, and we're making changes to our infrastructure. And I think other water utilities are going to be faced with increasing risks to their water infrastructure as well. I also mentioned the uniqueness of the 2019 or the most recent water year, and we expect more variability and potentially volatility in the future. So we're preparing for that as well. And so hopefully what you got from this is that you can see water managers like SNWA are adjusting the way that we plan and build, and we're trying to build more flexibility in our plans. And that's what I have.
Thank you, Keely. Thanks for those insights. And a look behind the curtain at some of the things that Southern Nevada Water Authority is doing to address climate change challenges. So this is a time now when folks can submit questions in the Q&A window, which you can access by mousing over the bottom of your Zoom screen. We have one question to start, and this one is for Brad. The question is, the CAP projection, Central Arizona Project projections, are for a reduction of approximately 1 million acre-feet towards the end of their 45-year planning horizon. Is this consistent with the predictions that you and Jonathan Overpeck found, with a possible 20% reduction in Colorado River flow by 2050 from your 2017 paper?
Thanks, Greg. So let me just talk briefly about that paper before I get to the answer. So in 2017, Overpeck and I produced a peer-reviewed paper called The Colorado River Hot Drought and Implications for the Future. And in it, amongst other things, we looked at and summarized the literature around what's called precipitation elasticity and temperature sensitivity of the Colorado River. Temperature sensitivity means how much does the river flow go down per degree Celsius increase. And we utilized previous literature that suggested that number somewhere in the area of 3% to 10% per degree Celsius, and the midpoint of that is 6.5% decline per Celsius increase in temperature. If you look out to 2050 and take the average of the climate models using that 6.5% per Celsius number, you come up with about a 20% decline in flow just due to temperature increases should precipitation stay the same. That 20% turns into 3 million acre-feet, right? If you know the average flow at least area is 15 million, 20% of that's 3 million acre-feet possible by 2050. Again, should precipitation remain flat? The question asked, is 1 million acre-feet suitable, or is it in the lines of what we suggested? And if I understand the question right, and the question dealt with 1 million acre-foot in leaf area decline, you can see the mismatch between those two numbers. If the question somehow related to another number, then maybe I would have a different answer. And one final point is that heretofore at 2020 approximately, based on temperature increases that we've already experienced, the river's lost about 6% of its flow already. So that's kind of a long-winded answer to that question.
Thanks, Brad. We're not seeing any other questions, so I will pose one to Keely. Keely, you mentioned that the Southern Nevada Water Authority and other water utilities around the Southwest are already seeing some of the kinds of what had formerly been projected changes. We're seeing that as some of the current reality in climate and water in the Southwest. So I'm wondering what additional information would be useful to Southern Nevada Water Authority, maybe to augment the kinds of information that you get from the National Climate Assessment. I'll leave it at that.
Sure. So as I was mentioning that we're starting to delve into what kind of impacts we might be facing on our personnel and in our HVAC, our heating, ventilation, and air conditioning units. And one of the variables that we don't talk about very much, or at least isn't really brought up in the the Southwest chapter or in the NCA is relative humidity. And this is an important component when you're starting to look at heat index and the experience of heat stress on people. It also stresses the evaporative coolers or chilling HVAC units that you use at your you know, to cool our office buildings as well as our infrastructure. And so we don't really have good information on how that's changing. We're doing our current study is looking into that, trying to extract some of that information from some of the downscale data. But I think for the smaller utilities that aren't able to launch that kind of effort, I think it would be helpful just to mention some of these other variables that will come into play when you're starting to look at these other types of impacts.
Thanks. Thanks.
Another thing I would just add, and I know that there's challenges with this kind of information coming out of the climate models and then the downscaling, is wind. We found that our water demand is impacted by wind quite a bit, how windy it is on any given day. And so that's another variable that we'd be interested in learning more about, what the projections are saying in terms of what's happening with wind in our region.
Okay, thanks. Yeah, wind is tricky, and there's lots of uncertainty in the current set of model projections. We've got another question. I'm going to guess that this, well, either of you could probably take this, but I'm thinking it might be more related to Brad. I'll read this off and we'll see if we can make sense of it. It's a two-part question. The first is agriculture in the states dependent on the Colorado River changing their water usage as an industry? Not sure if I really understand that. Might need a little clarification. The second part is, which states are incentivizing or disincentivizing water conservation and water use?
So, okay, let me take a crack at this. So somewhere north of 70% of Colorado River water goes to agriculture. Agriculture in the basin is highly variable, from alfalfa and pasture grass in large portions of the upper basin to very sophisticated irrigation dependent agriculture in the lower basin, where just about any crop gets grown. Lower basin ag around Imperial and Yuma near the Mexico border generates much of our winter vegetables and is a large economic driver in that area. So places like Imperial have given up significant amounts of water to municipal users in Southern California. In the case of Yuma, there are very sensitive politics around farmers and growers in Yuma with respect to Central Arizona and its desire for stable water through the Central Arizona Project, which I assume most people know is junior and is actually going to face its first ever shortage delivery this coming year. So with regard to the second part of that question, which states are incentivizing, disincentivizing water conservation use, I would tell you that because ag is such a large portion of use, it's a topic that everyone wants to discuss. Different states are approaching it with different levels of interest and vigor. You know, recently there was a system conservation pilot project effort, both in the lower basin and the upper basin, and most states participated in this effort to reduce water use, mostly ag, but occasionally I think there might have been a municipal project or two, in the interest in the upper basin of trying to preserve elevations in Lake Mead and some of the other Colorado River reservoirs. In the lower basin, the idea was to try and protect Lake Mead. And clearly, most people think those efforts, I would argue, were a success, although to scale it is an enormous challenge. I would argue that my state of Colorado is in some ways ahead of the game, and it's partly an outcome of the fact that we are so lawyered up and engineered up in this state, and have always been so because of the way we have dealt with the doctrine of prior appropriation around water law, where we have a whole set of water courts, and historically we've had large numbers of people who've been devoted to quantifying water rights decrees and change cases and the like. And this is both a good thing and a bad thing, but certainly within this state, we're more aware of our water use and where it goes and who uses it, who's entitled to it than almost any other state in the Western U.S. Arizona, is because of the drought contingency plan and the fact that it was sort of in the bullseye due to the way that the 1968 Act that authorized the Central Arizona Project made Arizona junior. It is dealing with these issues as we speak, and it's obviously very politically sensitive, especially with regard to Central Arizona versus the more senior rights that exist along the main stem Colorado. And just within the last day have been yet another article that you might want to look about Queen Creek in Central Arizona wanting to acquire water rights from the main stem Colorado and the controversies that surround it, in this case, ag to municipal use. So long-winded question. I mean, whole seminars and conferences could be organized around these two questions.
Yeah. Keely, do you have anything to add to that?
I think Brad did an excellent job of answering the question.
Yeah.
I'll just note though that Nevada doesn't have an appreciable amount of ag, so I guess we're fortunate in that regard.
Yeah. Okay. Thank you, and thanks, Brad, for your reply. That was very complete for a challenging pair of questions. We're at the hour, so I would like to cue up the virtual applause for our speakers and thank everyone for tuning in to the webinar. We will have another NCA webinar coming up in December, on December 12th at 10 a.m. Mountain Standard Time, and this one will focus on ecosystems. So thanks for tuning in, and we'll see you next time. Thanks.
Thank you.
Greg. Thanks, Brad.
Thanks, Keely.